Okay, so we just went over Dalton's law, which states that the total pressure of a mixture of gases is the sum of the pressures of the individual gases. I'm going to skip over these next couple laws because they're basically just extensions of Dalton's law. And we are now going to move on to this fourth law here, which addresses pressure gradients. Okay. So basically, this law states that gases move down pressure gradients. So gases, singly or in a mixture, move from areas of high pressure to areas of low pressure. Okay, so just like what we saw with liquids when we were looking at blood in the cardiovascular system, moving from areas of high pressure to areas of low pressure, air is also going to move from areas of high pressure to areas of low pressure. Okay. However, so I do want to point out, so that's what kind of governs our weather patterns. And also this is what governs the movement of air into and out of our lungs. Okay. But I do want to emphasize this phrase right here, singly or in a mixture. So what this means is that individual gas species, such as oxygen or carbon dioxide, are going to follow their own pressure gradients. So oxygen is going to move down its own pressure gradient. Carbon dioxide is going to move down its own pressure gradient. Okay, so to illustrate this concept, let's take a look at this situation right here. Okay, so what we're looking at is the air in the lungs, the alveoli. And then out here, we have the air in the atmosphere. In the atmosphere, we have a PO2 of 160 millimeters of mercury and a PCO2 of 0.25 millimeters of mercury. In the alveoli, we have a PO2 of 100 millimeters of mercury and a PCO2 of 40 millimeters of mercury. And the question is this: in which direction will oxygen and carbon dioxide move in this example? So go ahead and think about that for a little bit. Hit pause if you need to. Okay, so hopefully you figured out oxygen is going to move from the atmosphere into the lungs because we have a higher partial pressure of oxygen outside the lungs than inside the lungs, right? So we're moving from 160 to 100 millimeters of mercury. Carbon dioxide is going to do the opposite. It's going to move down its pressure gradient from 40 millimeters of mercury in the alveoli to 0.25 millimeters of mercury in the atmosphere. Okay. All right, so we've gotten through most of these gas laws. We have our three laws that have to do with Dalton's law. We talked about how gases move from high to low pressure. Now we are ready to talk about our last gas law, Boyle's law. Okay, so to illustrate Boyle's law, let's first take a look at this diagram here. Okay, so we have a container of a certain volume with a certain number of gas molecules inside. And what I would like you to do at this point is to consider this question right here. What is going to happen to the number of collisions if we decrease the volume of this container? So think about that for a second. Okay, so if we decrease the volume of the container, we should increase the number of collisions, right? There's less space for these little gas molecules to bounce around. They're going to end up colliding into each other more. They're going to end up colliding with the walls of the container more. So what that means is that pressure is going to increase, because remember that pressure is basically a reflection of how many collisions we have between the molecules and between the molecules with themselves and between the molecules and their container. Okay, so basically we have this inverse relationship between volume and pressure. As we increase volume, pressure goes down. As we decrease volume, pressure goes up. And that can be expressed mathematically using this equation, P1V1 equals P2V2. Okay, I don't think I'm going to have you do any of those calculations, but as long as you understand the concept. Oh, There we go, sorry. So we have, yeah, a volume of 1 liter, pressure of 100 millimeters of mercury. If we have that pressure to 0.5 liters, our pressure goes up to 200 millimeters of mercury, according to Boyle's law. Okay, now let's apply Boyle's law to the respiratory system. Okay, so taking a look at this figure here, as we breathe in, which is a process that we refer to as inspiration, when we breathe in, the volume of our lungs increases. Thinking about Boyle's law, what is that going to do to pressure? So think about that for a second. Okay, so hopefully you figured out if we are increasing the volume of our lungs, that is causing the pressure of the air in the lungs to decrease. And then conversely, if we look at the process of expiration or breathing out, what happens when we breathe out is we decrease the volume of our lungs. Okay, if we decrease the volume of our lungs, what is going to happen to the pressure of the air in our lungs? Think about that for a second. Okay, so hopefully you figured out as we decrease the volume of air in our lungs, the pressure of the air in our lungs is going to increase. So this is going to, we'll talk about it more later, but this is going to govern the movement of air into and out of our lungs, okay? All right, so that basically wraps up our discussion of gas laws. These are our 5 gas laws. I don't think I need to read them. I will see you next time.